In this part of the lecture, I want to talk about an interesting feature of classical logic that the rule of reductio ad absurdum helps us see clearly. Now, in order to do that, let's start out by looking at an interesting sequent. So consider this sequent: P, not P, therefore Q. Let's go ahead and prove this. So I'll begin by writing down my premises. Now my goal is to prove Q, but it's not clear how I can do that given the premises that I have in light of my other rules. And our new rule of thumb tells us that when we're stuck, when we've exhausted all of our other options, all of our other rules of thumb, it's a good idea to go ahead and try a proof by way of reductio ad absurdum. So that's what I'm going to do. My goal is to prove Q. So I'll try to do that. I'll try to prove that by way of reductio ad absurdum. So I'll go ahead and assume not Q on line 3 and make it my goal to derive a contradiction. Now in this case, it's fairly easy for me to get a contradiction because my premises are contradictory. I have P on line 1 and not P on line 2. So if I put those two together by way of conjunction introduction, I get P and not P, which is a sentence of the form B and not B. That is, it's a conjunction where the second conjunct is the negation of the first. That's what a contradiction is. So now that I've got that, I have derived my contradiction. So now all I need to do is discharge the assumption that I made for the purpose of reductio on line 3. I do that by applying conditional proof to lines 3 and 4. So now I have a conditional whose consequent is a contradiction. So by the rule of reductio ad absurdum, I'm entitled to infer the negation of that conditional. So I'm entitled to infer the negation of the antecedent of that conditional. So I get not Q on line 6, that being the negation of not Q. And now that I've got not Q, I can go ahead and apply the rule of double negation to achieve my goal of proving Q. Okay, that was a fairly simple proof, but here's something interesting about it. Q didn't really have any kind of obvious relation to the premises whatsoever. I could have put R in for Q and run this same proof. I could have put R or Q, or if Q then R. I could have proven any of those statements from P, the premises P and not P. I could have proven any statement whatsoever in just precisely the way that I did here, by way of reductio ad absurdum. And the reason that I could have done that is because my premises themselves are contradictory. So what this proof shows us is that classical logic is what logicians sometimes refer to as explosive. That is, according to classical logic, any statement whatsoever follows from a contradiction. Any statement at all follows from contradictory premises. Now this is an interesting feature of classical logic. But one might not think it's such a troubling feature. I mean, after all, if one has contradictory premises, then in a certain sense one's premises are garbage. They can't all be true together. And you might think, well, garbage in, garbage out. It's fine to let it be the case that anything whatsoever follows from a contradiction. This shows us why we ought not have contradictory beliefs. Well, some philosophers have thought that this actually shows that there's a problem with classical logic. They have thought that it is a defect of classical logic that it is explosive, and that this is a reason not to endorse classical logic. That is the kind of logic that we've been learning in this course. This might surprise you a little bit. You might have thought that, sure, there are many controversies in philosophy, but one thing that's not controversial is the logic that we use. Everybody should be able to agree on that. But as a matter of fact, not all philosophers do agree on that. So I think that this shows that there is a problem for classical logic? Well, let me give you an argument against classical logic that exploits this feature of it. So here's our first premise. If classical logic is correct, then it always serves as a means by which one may infer beliefs that it is reasonable for one to hold from other beliefs that it is reasonable for one to hold. And at first glance, at least, this premise seems right. Seems like this is the point of logic. The point of logic is to show us what follows from what is reasonable for us to believe, so that we can go ahead and believe those things too. Okay, second premise. It is reasonable for one to hold contradictory beliefs. Now I suspect that this premise does not look true to you. It doesn't seem at first glance that it is reasonable for one to hold contradictory beliefs. But there are actually some powerful arguments for the conclusion that, at least in certain kinds of situations, it is reasonable for one to hold contradictory beliefs. And I'll give you an argument for that claim in a moment. So let's just put this premise aside for now and keep filling in the argument. Okay, third premise. If 1 and 2 are both true, and classical logic is correct, it is reasonable for one to hold any belief whatsoever. Okay, this premise exploits the fact that classical logic is explosive. So if classical logic serves as a means by which I can infer beliefs that it's reasonable for me to hold from other beliefs that it's reasonable for me to hold, and it's reasonable for me to hold some contradictory beliefs, and anything whatsoever follows from contradictions, then I can infer anything whatsoever from what it's reasonable for me to believe, because among what is reasonable for me to believe are contradictory beliefs. But then, given premise 1, it's reasonable for me to believe anything whatsoever. Okay, but it's not the case that it's reasonable for me to believe anything whatsoever. It is reasonable for me to believe, for example, that the Earth is the third planet from the Sun, but it is not reasonable for me to believe that the Moon is made of cheese. There are things that it would not be reasonable for me to believe. Okay, well, it follows from these premises that classical logic is not correct. This is a valid argument. So, for those who, like me, are fans of classical logic, for those who, like me, think classical logic is correct, it is incumbent on us to find a premise of this argument to deny. But which premise should that be? Well, you might think that the culprit is premise 2, that it's reasonable for one to hold contradictory beliefs. But as I mentioned, there are actually powerful arguments for the truth of premise 2. Let me give you one. So here's a famous paradox in philosophy called the paradox of the preface. So suppose you have a highly competent and well-regarded scholar who has meticulously researched a number of claims that she asserts in her latest book. And in the preface of the book, she sincerely reports that while she believes each and every claim in the book, she is well aware of her fallibility, and she humbly admits that she believes that at least some of the claims that she has asserted in the book are false. She doesn't know which ones. For any given belief, she believes that that belief is true, but she doesn't believe that the entire conjunction of those beliefs is true, because she recognizes her fallibility. Well, it seems that each of the beliefs that the author reports that she has might well be reasonable for her to believe in this scenario. It seems like it very well may be reasonable for her to hold each of the beliefs that she reports in the book, and also reasonable for her to believe that at least one of those beliefs is false. Okay, but these claims are jointly inconsistent, or these beliefs are jointly inconsistent with each other. The beliefs asserted in the book minus what's asserted in the preface jointly entail that the conjunction of those beliefs is true. She could infer the entire conjunction of those beliefs just by repeated application of conjunction introduction. But the belief that she reports in the preface implies that at least one of those beliefs is false. So her beliefs are contradictory. Nevertheless, it seems perfectly reasonable for her to hold each of these beliefs. So I think that premise 2 is in fact true. I think in cases like the case described in the paradox of the preface, it is reasonable for one to hold contradictory beliefs. And actually, this applies to each of us. For any given belief that I have, I'm willing to stand by that belief. The nature of believing a claim is to be, part of the nature of that is to be willing to stand by its truth. But I recognize that I make mistakes, so I also believe that at least one of the things I believe is false. Those are contradictory beliefs, but they're reasonable beliefs for me to hold. So, even though I'm a fan of classical logic, I'm not going to try to get out of this argument by denying premise 2. I'm going to look for another premise to deny. Well, for what it's worth, my money is on the falsity of premise 1. I deny that if classical logic is correct, it always serves as a means by which one may infer beliefs that it is reasonable for one to hold from other beliefs that it is reasonable to hold. Many philosophers, including me, hold that classical logic is correct, but it's not always reasonable to believe the logical consequences of one's reasonable beliefs. Classical logic can tell you what those consequences are. Sometimes classical logic can show you that the consequences of your reasonable beliefs are absurd. Sometimes that should put pressure on you to revise those beliefs, rather than simply endorsing what follows from those beliefs. In other cases, like the case described in the paradox of the preface, I think the reasonable thing to do is simply to hold on to one's original beliefs and recognize that one shouldn't endorse all the logical consequences of those beliefs because they are in fact contradictory. This is my own view. You are free to disagree with me, but you should understand what it is for classical logic to be explosive, and you should know how to be able to, or you should know how to demonstrate that via using the rule of Reductio ad Absurdum. That is, you should be able to reproduce the interesting sequent that I discussed in this part of the lecture. Okay, thank you. I have given you some exercises concerning Reductio ad Absurdum so that you can get some more practice applying this rule.